Hello, hello. Testing. Okay.
new document format to be able to send documents to the printer and have the printer actually understand what was going to be printed out. Now, when we talk about these early printers, this is not something that you'd have, in your dorm room or on your desk or in your office, at least not any sort of normal office. I mean, these days, a printer like this is probably considered kind of large, but these early printers were like minimum the size of like a large floor-standing photocopier. On the higher end, it would have been like as long as this entire room. So these are very large, very expensive machines, and there was a lot of serious effort going into this. Over the span of a few years, these printers were developed, and a few different formats were developed and tried out at Xerox, sort of internally. But like most things, you don't get it perfect on the first try. So they went through a few different iterations because they started out, and the first attempt was like, okay, this works, but it's not very flexible. It doesn't fulfill all of our needs. And then they kept working on it, and it got more complicated. And then eventually they had something that were like, well, this is too complex. We need to kind of scale back and find a balance. So by the third project or so, they had they would like try something for a year or two and then like sort of abandon it and do something else. By the third time, the computer scientists at Xerox were honing in on something pretty practical, but they were struggling to convince the business higher-ups at Xerox that what they had was something that was financially viable and sort of commercially valuable outside of their company. And so two of those people, John Warnock and Chuck Geschke, if I'm saying that correctly, went off on their own, and they actually founded Adobe Systems Incorporated, which of course still exists today and is now called Adobe Inc. I'm sure everyone is very thrilled to hear that company name. And at Adobe, that's where a handful of smart people, so those two founders and then a few other people that they recruited, got together in the early 80s, and they created PostScript. And that was sort of an amalgamation and sort of a lessons learned from what they did at Xerox. And so it was kind of based on that last work that they were doing before they left. So the basic idea with PostScript is that you write this program on the computer, and it generates a document using text and graphics primitives. And instead of doing that generation on the computer and then sending over the result, you actually send the program to the printer, and the printer executes the program. The printer does the rendering, and the printer puts it on the page, of course. And so this was kind of, this might sound kind of backwards in today's world of computing, but these were the days of really limited, computer resources and really expensive printers. And so this was the thing that sort of made the most sense. So it's the early 80s now. Apple is working on the Macintosh, of course, and they're also working on a high-quality printer to go with it that people could actually afford to have in their homes and in their offices, because that's sort of a novel concept then of home printers that could actually produce print quality prints, right? Like something that looks like something you might find in a book or a newspaper. That wasn't something that people generally had back then. And so when Steve Jobs learned what Adobe was working on, he was both interested and also very impressed. And he actually tried multiple times to buy Adobe outright, and they refused. No, we don't want to sell it. And so instead, Apple actually licensed PostScript from Adobe so that they could incorporate it into the Mac and into this printer platform that they were building. And so the release of those two products, this printer, which actually is on your next slide there, and the Macintosh, early Apple Laser Writer. Those two products combined sort of sparked this industry excitement in the 80s of desktop publishing. That's kind of when that began. Sort of a revolution of what people could do with equipment that they could afford. So PostScript support made its way into many different computers and printers over the next few years, starting in 1985 when that printer came out. And this went on for a while, but there was ultimately a problem, which was that PostScript was so flexible that it was actually very costly to implement. This printer, I think, costs about $5,000, and that's in 1985 money. So I don't know. Do the math on inflation, but that's probably like competing with a motor vehicle, I'd imagine. Yeah, the printers had to contain all this, computer logic in them to be able to execute these PostScript programs, and so it was impossible to make a cheap printer that worked with PostScript at the time. And so, in the first few years of this, the early days, wasn't a huge deal because making a printer like this costs a lot anyway. And if you're putting all that hardware in there anyway, maybe not such a large deal to have the computational stuff in there as well. But the industry's working on that as well. They want the printers to be cheaper, and eventually the cost of the printer mechanisms began to fall. And this problem of we can't put PostScript interpreters in all these cheap printers, became more relevant. And so luckily, at the same time, computers were also becoming more capable. And so there was sort of this industry shift. So what happened was, instead of doing this sort of PostScript method of sending programs over, they shifted that rendering of the documents over to the computer side, rather than doing it all inside the printer. And so during the 1990s, printers became much more affordable and ubiquitous, and many of these did not actually support PostScript. Although PostScript support continued on many Office printers. So we have this modern-ish Office printer here, and it's still happy and well to accept a PostScript document. There were a few different versions of PostScript. There were basically 3 major versions, and the last one was released in late 1997. So just to kind of give you an age of when the development sort of stopped was around the late 90s. And you're probably wondering, well, where does PDF fit into all of this, right? Because PDFs are sort of the ubiquitous document format these days. And indeed, PDF is probably the closest thing to PostScript's direct replacement. PDF was first developed in the early 90s by Adobe, the same people who developed PostScript. And it really, sort of took hold later in the 90s as PostScript was sort of starting to be phased out of it. But PDF was not free of its, sort of PostScript ancestry. PostScript, a subset of PostScript actually exists in PDF, and that sort of forms the basis of what PDF is. But they sort of made some important improvements. So yes, you're still sending this file over to the printer, but instead of it being a program, it's more of a description of the document. And that actually ended up being quite important because that allowed PDF to be useful for other things other than printing. When you need to execute a program to be able to render your entire document, that means you cannot skip around willy-nilly and just, skip straight to page 500. You got to render all the pages before that to know that those previous pages aren't going to affect page 500. So that was kind of important. They did other useful improvements, like Adobe added the ability to embed the fonts that you were using in the document into the PDF file itself. So you could just send one file, and it didn't matter if your client had some font installed that you used. It didn't matter. You send that to the printer, and the printer can print it. And also that shift away from executing code in the printer also kind of reduced the security risk footprint and allowed for a simpler implementation. Although, of course, PDF these days is quite complex. That ended up being a more economical choice for cheaper printers that were coming out in the late 90s and early 2000s. But again, sort of PostScript sort of lives on in this niche. That's what I've got for now.
Okay. Yeah, so just to reiterate some of the main contributions of PostScript, a lot of it was in improving the quality of printed documents as well, because this is, for example, an advertisement from Adobe, some sort of like font forge program that they wrote. And so they're showing kind of on the left with a printer that doesn't support PostScript, how the fonts are all bitmapped, so pretty pixely. And then after they invented this language for creating vectorized page descriptions on the printer itself, then they show kind of the improvement of the print quality. So this is just an ad from the 80s that I found on the internet. But anyway, let's get started with actually doing some stuff. So if you guys want to play along, you can open up this link on the bottom in red. It's sort of a little interactive page where you can type in PostScript code and then press a button and see what it looks like. So try to follow along if you can. I'll give everybody a minute to get that open. And then we'll write our first PostScript program together. And PostScript, as some of you might know, is sort of a weird programming language compared to other ones because it's stack-based. So the only other example I can think of is Forth, which most of you have heard of. Anyone know other stack-based languages?
The Python bytecode, like UIC.
Okay.
Stack-based, so it's Java bytecode. Like.
Yeah.
Orbital with multi-assembly?
No, those are register-based.
Depending on how you use it, sometimes that's what's wrong.
Okay. Well, anyway, we'll get started with this. So the blue is the source code. You guys can type that out while I'm talking through it. But the first line is kind of like a shebang. It just marks that this is the beginning of a PostScript document. Sometimes you'll see a little bit afterwards, some stuff after the exclamation point. It says like a version. So maybe it enables some other PostScript features. But by default, like the simplest, you can just do %! to mark PostScript file. And then the second line just is choosing a font. And so now we'll go to the third line, and you'll see it looks kind of weird compared to a conventional programming language. I mean, this is what a stack-based language looks like. If you've ever heard of reverse Polish notation, like a form, like the way that old calculators worked. Yeah, postfix. That's why it's called PostScript. I'm pretty sure. I might be making that up, but let's say that that's the reason why it's called that. But the way that it works is the arguments come before the function that calls it. And so the whole idea here is that 75 and 50, which are the XY coordinates, I should rewind a little bit in saying that the whole concept of this is that you have an empty page, a blank page, and you have a little pen, and you can move the pen around, and you can draw stuff, or you can put text wherever the pen is. So that's the cursor. And so the move to command will move the cursor to some coordinates, x 75 and 50, or y 50, as you can see there in the bottom. This is in points, which is 1/72 of an inch. It's a typesetting standard unit. But yeah, it's in points. Anyway, so okay, so now we've moved the cursor. And again, it's this reverse Polish notation, and we'll talk about what this actually means in a second. And then finally, when we've moved our cursor there, the way you mark strings is with parentheses, which is interesting. And then the show command will take whatever string precedes it and put it on the page. And then finally, show page is the command to actually print the page to say that it's done. So did you guys try this out? Did it work?
Yeah.
Okay. Nice. All right. So I'm going to keep moving forward.
Yeah, note that the coordinates start at the bottom left corner.
Right. Okay. So I'm going to go into just a brief detail of what a stack-based language means. Most of you know what this is, but some don't, so I'll just bear with me. So as we mentioned before, compared to a conventional programming language where you might have like move to parentheses and then the arguments to move to, like XY coordinates to move the pen. In postfix notation and most stack-based languages, the arguments come first, and there's also no parentheses or anything to sort of mark the arguments to a function. So this is postfix notation. And the way that you can think of it, for example, let's say we want to multiply two numbers in PostScript and then get the result. So the way that this works is in blue here. Where's my cursor? 5.3 mol. So what this actually means conceptually, if you imagine a stack, which if you're not a CS person, and there's at least one person here that's not, you imagine a literal like stack of blocks. They could just be they're just physical blocks, and you put a 5 on the stack at the bottom, and then you put 3 above it, and then now you run this command called mul, and all it does is it takes the top 2 blocks off of this stack of blocks and it replaces it with the result. And this is the whole concept of what a stack-based language is. And you might say, like, what is this weird system? Why are we even thinking about it this way? I think it's the main reason is that it's very easy to implement, and it's very you can have a very simple computer implement this sort of programming language, which is.
I mean, they were running these things on printers, so.
Yeah. So that's the main reason for having stack-based languages, simplicity of implementation. And so just to point out, some operations like multiplication, they put stuff back on the stack, but some of them don't. So for example, we saw move to earlier. You put the coordinates, we put 75, 50 on the stack, and then move to will take the top 2 items off the stack, the coordinates, and then move the cursor, and it won't put anything back. There's no result from that operation. So some generate stuff and some don't. Now getting a little bit more into the weeds. Variables, they're created like this. I mean, you do a / variable name, whatever you want to put into that variable, and then you end with def. And you can think of this also as like a stack operation too, but and then if you want to reference it, you just don't use the slash. So you could store, if you want to like save coordinates into a variable, for example, like I'm doing here, you could do that. Functions are interesting in stack-based languages because basically what this is saying here. So let's say we want to have a function that converts from points, which is this weird type setting unit, and we want to just think in inches instead. So we want to have a function that converts from points to inches. So the way that we do that is this is our function here, 72 mol. So what this will do is this will take whatever's already on the stack, for example, a 5, and then it will insert after that 72 mol. So we'll have 5, 72 mol, and then that will convert 5 inches times 72 to some result, 360. And so anyway, now we have this move to command, which is in inches, if you wanted to do it that way. So that's functions, which are actually called, in PostScript, they're called procedures. And they use curly braces. PostScript has a few data types. There's some generic concept of a number, which can be an integer or a float in scientific notation, or just a decimal. And it can also accept hexadecimal strings. I think there should be a space here. As we saw before, we can have strings, and we denote them with parentheses. They can have new line characters in them. And then the strings are allowed to split across multiple lines if you wanted to do that. Yeah, it does. And then names are another data type, and that's a variable marker. So that's its own data type, as we saw before. And then some other stuff that we're not really going to use today are arrays, and even more complex are dictionaries. So it's got all these data types.
There's also Booleans too, which are used for control flow features. Yeah,
I should have put that here. Okay, so this slide is just saying like how to set up your system. So if you guys are on this app already, or this webpage, you should be good. So let's do some more. I'll go through some more examples here. We already saw the %bang, which marks the beginning of a PostScript program. We saw how to move the cursor to a specific spot. And now we'll actually start drawing something. So PostScript has this idea of you are currently drawing a line or not, whether you are creating a new path or not. So there's certain commands that will trigger the creation of a new path is the language that they use. And one of them is line 2. And so that means draw a line from the current location to this new coordinates, absolute coordinates. And there's also R line 2, which is a relative movement. And so what's happening right now is we move to 50-50, and then we do a movement to 150, which is here in absolute coordinates. And then we do a relative line upwards. So 0, we move 0 to points x and plus 50y, and that's relative. And then finally, we close the path. So we finish the triangle. And you could stop there and do a show page, and it would just be a black triangle. But you can do more fancy stuff, like set the width of the lines, which you can just look at the example here to make it extra thick. You can fill in the color. This gsave and grestore thing is a little tricky to explain, but it will do stuff like save the state of whether you're drawing a line or not, save the coordinates of the cursor in a page rotation. But you'll be able to play with this stuff later. So the details are not super important right now. I'll just go through a few more examples just so you guys can see kind of what PostScript is capable of, and then you guys will just have the chance to do your own stuff on that app and eventually print stuff to this printer we have set up. So now let's make a procedure. So I'm making a new procedure called long line, and all it does is first save the page state in the cursor position, most importantly. So wherever we are, it'll save the position. And then we'll just draw a really tall line straight up. From wherever we are, we're going to draw a line straight upwards. So that's 0, 1000, relative line 2. So we're doing a relative movement from wherever we are straight upwards, and then we stroke the line. So that means we've drawn this path, and now we actually apply the ink to it. We stroke it. And now we're at plus 1000. So we used to be in the middle here, or wherever we started. And then we moved up plus 1000. So if we want to go back, we could do a relative movement back down, or we could just restore our previous position. And so that's kind of, you can do these kind of, use these G saves and G restores to do some, if you use them periodically, it can make stuff simpler. So now we've defined this function. We haven't actually called it yet, clearly. So the next step in this specific program is move to the middle of the page, which is about 300, 400 points. That's about right here. So now I call long line, which does this sequence of commands, saves our position, draws a line straight up, and then reverts back to the original location. And then this 90 rotate. So the rotate command will take the whole canvas of the page, like the sheet of paper, and it will rotate it under the cursor. So I use that a lot for doing kind of weird patterns and stuff. So I like that command a lot. And then we just repeat it. So now we've drawn 4 straight lines, and then we show the page. So pretty simple. We can do some more interesting stuff. Using this long line command, we can draw straight lines and rotate the page by a little bit each time and do a little bit of offset, so we can kind of create these cool patterns. I don't know if this is in the examples on that application. If you guys go to the drop down on the top of that web app that you have open, you can load a lot of pre-made examples and play with them. And so there should be some examples like this that you can just tweak the numbers of and just generate different patterns. One other thing I want to point out is there's a repeat command. So basically you tell it how many times you want to repeat, and you give it some stuff to run multiple times. There's also for loops, and there's if else's and while loops, and a lot of other stuff that you can just Google if you're interested. So here's some other examples of stuff that I've generated over the years. These are both on that application, so you can load these examples up and modify them and do whatever you want. These are from a long time ago. I didn't make the one on the left, but someone actually made their own ray tracer in PostScript, which is kind of cool. It takes a few minutes, or not a few minutes, it takes like a few seconds to run. And then here's another one that I did myself. So just running over some final things. If you're interested, there's a lot of other commands, obviously, that we skipped. Here's some ones that are just have to do with stack manipulation, for example, like exchange, switch the top 2 items on the stack, or duplicate items, or remove an item. Like I said, there's arrays. So if you want to like loop over a list of items to do something with each one, that's the for all command. And then like there's if else and so many other operations. So there's links in this presentation if you guys are interested, or if you just Google PostScript tutorial, you'll find all this stuff anyway. So yeah, some final facts about PostScript. I mean, you should know this already from the history section, but a lot of, I guess not every printer, but a lot of printers accept PostScript directly and will do the rendering on the printer itself. So usually they'll be listening, the ones that support PostScript, they'll be listening on port 9100, so you can connect with Telnet or Netcat or whatever and just send them PostScript directly to this port that they're listening on, like this one right here. I think if you go into the settings and you turn off the Jet Direct option, it's usually called that. It's like some proprietary name for listening on port 9100. It's called Jet Direct. I think you could turn it off on some printers. Other stuff, if you've ever heard of EPS files, like if you've ever done LaTeX, that's PostScript. And it has some other features like this, defining the page size and things like that. And so, for example, LibreOffice can embed PostScript files directly inside it, which is kind of cool. So you can actually, I don't remember the file name, but you can have it, you can have a PostScript, like a .eps file embedded in LibreOffice, and then modify the file, and then it will just automatically update LibreOffice like an external. You can do that with images too, but I thought it was kind of cool. That's the end of the presentation. So just experiment with that web app, and then we have this printer set up, and we will, if you guys connect to the, yeah, I guess I'll finish what I'm saying right now. If you guys connect to the PostScript network, SSID PostScript, no password, you can send your stuff to the printer if you want to play around with it. Just don't send like pages of black ink, because we need to have this printer work for other years if this presentation happens in the future. So we only have this. What?
Can we start mining the currency on the printer?
Yeah, it's a laser printer, so it's black and white. Yeah.
So when I set up a printer, like completely unrelated to PostScript, when I set up a printer, and I configure a driver port, for example, there are generally 2 options that I see. One is generic PostScript driver, and one is generic PCL driver.
Yeah.
Can you touch on PCL?
PCL is a technology that was made by HP. It's similar to PostScript. I think it's probably a little bit less flexible, but it fulfills a similar thing.
And a lot of printers support both. So you can actually have a PostScript file, and then put like PCL commands in it, which usually start with like @PCL. So you can do weird stuff like set the text that shows up on the LCD to like insert coin or whatever, which we've done that before on this one. So you can like find printers on your network and send them PCL commands to change the LCD display. And of course, there's like no authentication on almost all of them. So yeah.
Why is there no standardized USB protocol for printers like there is for a keyboard or a mouse or one of other things? Because printer drivers are portable pain in the ass.
So in recent years, there actually has been a significant effort to do, these days everyone wants Wi-Fi support or network support. But I think it's the AirPrint initiative has kind of brought a lot of printer manufacturers together to settle on.
Yeah, and someone said IPP. So one of the guys that was working for Apple started this, and he's the one that created Cups, the printing system. He started working on this IPP standard so that basically you don't have to have drivers for printers anymore. I mean, he's been working on that for 20 years.
Wait, this is how I connect the ACM drive. I don't. How should you can do IPP over USB? And I just do that.
Yeah, so that's just like, instead of sending PostScript directly over the wire over TCP socket, there's this kind of like wrapper protocol that lets you, the printer talks back to you. It can describe its capabilities, and then you can send it stuff. And
yeah, to be clear, that's not a replacement for PostScript. That's a way you could send PostScript or some other thing, or PDF or whatever.
That's a replacement for this command here, though, this blue line. Yeah.
Does a modern printer still accept PostScript inputs, or is it some other format you can send them?
Some yes, some no.
I think most of them that support PostScript, you can still send it over this TCP socket, from what my experience.
No, I just press print on my browser and use hubs to send something to a printer. What does it actually send?
Well, it depends on how you set up the printer in cups. It could be sending it over IPP. It could be sending it over Jet Direct, port 9100, or some other number of ways. And also, it might be converting it to PDF first, because a lot of printers understand PDF in addition to PostScript. So usually it'll be converted to PDF on the computer first, send it over the wire, however it does that, and then the printer renders the PDF. But you can change the options, and yeah, you can change the options to in cups to make it send PostScript.
So now PostScript is like partly replaced by PDF, I guess.
I think most printers that have a PostScript engine also understand PDF directly as well. Okay, well, that's the end of the presentation. If you guys want to connect to the network, what was the IP for the printer? 103?
I think so, yeah.
Yeah. If you guys want to send stuff to this printer, you can do that here if you connect to the PostScript network, or just play around in your browser. Anyway, that's it. Thanks.
Thank you.
If you look at the ray tracing program, it looks pretty much like immersion. You try to explain that.
Yeah, there's a version of it that is not as compact, which if you open that link, I think that guy explains it. So he has like where is it? Yeah, anyway, this goes through all the details if you're curious. So this is the link here. I don't know how this works at all. I haven't looked into it. I just thought it was cool.
I'm surprised how compact it can be. It's like only 13 lines.
Yeah. But he describes how it works here. Again, I have no idea how it works. But I'll be walking around helping people if they have questions about stuff. So that's the end of the presentation.